Good morning, dear student. In previous lecture, we already discussed the polysaccharides and the classification of polysaccharides. So the polysaccharides are classified into two types. One is homopolysaccharides and second is heteropolysaccharides. So we already discussed what is homo and what is heteropolysaccharides. Again, this homopolysaccharide again classified into two types, that is storage polysaccharides and structural homopolysaccharides. Storage homopolysaccharides and structural homopolysaccharides. And the storage having two example, that is it is from two origin, one is plant and animal, and the example is starch. So in previous lecture we already discussed that is the storage polysaccharide which is present in plant, that is starch. And again, this starch, it is uh, it is a combination of two components, that is one is amylose and second is amylopectin. So we already discussed the characteristics of this amylose and amylopectin. So this amylose, so it is a linear polysaccharide. So what is the difference between amylose and amylopectin? So only the amylose is your linear polysaccharide while the amylopectin is your branch polysaccharides. Both are the important constituent of the starch. Okay. So what is this amylose? Amylose, it is a linear polysaccharides, and the monomer. Okay, amylose is a polymer. Okay, therefore it is considered as a polysaccharides. The monomer is your glucose. There is a alpha 1,4 glycosidic linkage. So number of monomers are joined by this alpha 1,4 glycosidic linkage. The structure of this amylose, it is in alpha helix form, and each turn of this alpha helix contain 6 glucose molecule. Its molecular weight, it is up to 60,000. Okay, its molecular weight is up to 60,000. And the important characteristics of this amylose, that is it shows blue color with iodine solution. Blue color with iodine solution. So these are the some important characteristics of this amylose, and this is the structure, that is alpha 1,4 linkage. So this is your alpha carbon. Okay, anomeric carbon. And this OH group and this CH2OH group is what? Trans to each other. Therefore this is your alpha glucose, and this is your carbon number 4 of second glucose molecule, and this is your carbon number first. So carbon number 1 and 4 undergo alpha glycosidic linkage to form the polymeric structure known as amylose. So it is a linear sequence. Okay, alpha D glucose, linear sequence of alpha D glucose, alpha D glucose, linear sequence of alpha D glucose. Okay, 1,4 linkage is there. So this is all about the amylose. We already discussed this point, and this is the structure. Okay, linear sequence of this glucose molecule. So let us discuss the second one, that is your amylopectin. So let us discuss the second one. This is your amylopectin. Amylopectin. So in this case, no doubt there is a 1,4 as well as 1,6 linkage is there. 1,4 as well as 1,6 linkage is there. So if we draw the structure like this, okay. So this is your linear sequence of this glucose molecule like this. And this is a continue. Okay. So this is your 1,4 linkage. This is your 1,4 linkage. Okay. This is your 1,4 linkage, and sometimes there is a 1,6 linkage also there. So for okay, so we also shows the 1,6 linkage. So this is your carbon number 1. This is 4, 1 and 4. Okay, this is your alpha 1,4 linkage, alpha 1,4 linkage, and the remaining is as it is. And this amylopectin, it is not a linear polysaccharides, so it is a branch polysaccharides, so it will interact. Okay, so this position, so it will interact with the 6 carbon. Okay, it is not carbon, it will interact with the alcoholic group of the carbon number 6 with elimination of one water molecule. So the oxygen is there, and this is your CS2 is there. Okay, and this CS2 which is attached to this glucose molecule. So like this. Okay, and this is also the linear sequence. Okay, like this, and this is continue. Okay, so this is your 1,6 linkage again. If you see this is also attached to this. Okay, so I will draw this. Okay, so like this again, this it will gives. Okay, so this is your linear sequence. So this is your 1,4 linkage is there. Okay, and there 1,6 linkage is also there. 1,6 linkage is also there. So remaining is like this. Okay, so this is your 1,4 as well as 1,6 linkage. 1,4 and 1,6 linkage. 1,4 and 1,6 linkage in amylopectin. So amylose, okay, and amylopectin is a constituent of this starch. One is branch, another is linear. So amylose is a linear polysaccharides, and this amylopectin is your branch polysaccharides. So it contains both 1,4 linkage as well as 1,6 linkage. Okay, 1,4 linkage as well as 1,6 linkage. And if you see the properties of this amylopectin, if you see the properties of this amylopectin, then it is a branch polysaccharides. So the first point is that it is a branch polysaccharides. It is a branch polysaccharide. Then it have both 1,4 and 1,6 linkage. 1,4 and 1,6 linkage. Each branch contain, so if you see this, each branch consists of 20 to 25 glucose unit. Each branch is consist of 20 to 25 glucose unit. 20 to 25 glucose unit by 1,6 linkage. By 1,6 linkage. Okay, each branch, so there is a branch. Okay, and each branch having 20 to 25 glucose unit by 1,6 linkage. By 1,6 linkage. This amylopectin also gives the glucose molecule which on complete hydrolysis. So after hydrolysis in the cleavage, there is a cleavage of this glycosidic bond, and it will forms the glucose molecule. Okay, again, we already discussed that its molecular weight is lie between its molecular weight is higher than that of amylose. Okay, than that of amylose, and it gives red to violet color with iodine solution. The next important point is that it will use or red to violet color with iodine. So this is the characteristic property of this amylose and amylopectin. So if you want to distinguish between this amylose and amylopectin, so amylose, it will gives the blue color, characteristic blue color with iodine solution, while this amylopectin gives a characteristic red to violet color with iodine solution. So this is all about the storage polysaccharide, that is your starch. Okay, in the next lecture we will discuss the remaining polysaccharides, that is either it is storage or structural polysaccharides. Okay, so this is the starch is your storage polysaccharide. Its origin is plant, and it is it having two main constituent. One is amylose, another is amylopectin. So amylose, it is a linear sequence of this glucose molecule, joined together by 1,4 linkage and to form amylopectin. While this amylose, and while this amylopectin, it is your branch polysaccharide, and it is formed by 1,4 as well as 1,6 linkage. And how will you distinguish this amylose and amylopectin? Amylose gives blue color with I2 solution, while this amylopectin gives a red to violet color with iodine solution. Okay, so this is all about the polysaccharide, that is storage polysaccharide starch. In the next lecture we will discuss the remaining point. Thank you.